Current System Part 5, the importance of patching the growth of waves. Whenever the winds blow over the surface of the water, the friction or tractive force of the wind creates waves in the water. The stronger the wind, the higher the waves. In the open ocean, the size of waves depends also upon the depth of the water, the length of time the wind has been blowing, and the fetch or distance to windward over which the wind blows initially. The waves are short and steep, but if the wind continues to blow in the same direction, they gradually become longer and their heights increase. The high seas of the roaring forties, for example, are generated fairly consistent strong winds of virtually unlimited pitch. The importance of pitch is because when they come from shore and to the sea, and if the winds continues to blow in the same direction, they gradually become longer and their heights increase. When we say roaring forties, they are strong westerly winds found in the southern hemisphere between the latitude 40 and 50 degrees. Did you know that during the Age of Sail, the roaring forties were a major aid to ships sailing the brewer route from Europe to the East Indies or Australasia? Dorresteyn's nomogram for forecasting significant wave heights. Dorresteyn's nomogram for significant wave heights, assuming a knowledge of the wind speed, duration, and pitch. One can read off from the nomogram the corresponding significant wave heights. Dorresteyn's nomogram helps us to forecast the resulting wave heights. In order to obtain the significant wave heights, you need to have the three, assuming knowledge: the wind speed, duration, and pitch. Here are the additional information about the wind speed, duration, and pitch for better understanding about the Dorresteyn's nomogram. Wind speed. For generating wind waves, we obviously need the wind to blow over a water surface. The wind will then transfer a small part of the energy to the water due to friction between the two fluids, the water and the air. And due to an excess in pressure on the windward side of waves compared to the pressure on the leeward side, the energy will then move as a wave along the surface of the water. But the water itself will almost not move. Inside the waves, the water moves in a circular motion forward and backward, up and down. There is thus almost no forward movement inside the wave, but it's only the wave energy that moves. The stronger the winds blow, the more energy will be transferred and the higher waves can be developed. But wind can't stand alone. Duration. A strong wind gust will only form ripples on the water surface. On the contrary, a strong breeze with 22 to 27 knots blowing over a sea surface for many hours will generate waves up to about 3 meters. The duration of a certain wind strength is thus just as important than the strength itself, but wind and duration can also not stand alone. Lastly, pitch. If a strong breeze blows in 2 days from land towards sea, you still have very low waves near the shore. This is due to the small wind pitch, that distance traveled by the wind across open water. For waves to rise, the pitch over water must be relatively long. The longer the pitch, the less limiting will the pitch be to the height of fully developed waves. With above 3 ingredients in mind, it's now possible to forecast the resulting wave height with below nomogram. Let's learn how to use it by an example. If you are looking for graph, you will see it at the next slide, and the highlighted words are given that will help us to forecast the resulting wave height. If the mean wind has a speed of 10 meters per second and a duration of 12 hours, You must follow along the line with the red arrow until you reach the vertical 12-hour line, which is encircled with a red circle. Now you must follow a horizontal line towards left and read the height of resulting wave. In this example, you get 2 meters, which is encircled with a blue circle. However, this will only good estimate if the fetch is not at least 150 km, which is encircled with a green circle. If the fetch is limited to 100 km, the wave height will only rise to 1.8 meters. After around 36 hours, the waves will be fully developed at about 2.3 meter and will thus not rise any longer even if the wind duration would be a week. By the way, you can also read that the resulting wave period will be about 5.5 seconds after the 12 hours and increasing to about 6.3 seconds for the fully developed water. Waves. The wave periods are the dotted lines in the nomogram. Here is the graph. As you can see, all the given in the previous slide is being plotted here.
The relationship between sea waves and swell waves. So, swell are waves that have traveled long distances from the area where they have formed and have decreased in height. Their tops appear oily and do not wake. Sometimes, waves and swells are observed together. This is because in the area of observation, waves are being generated by the wind blowing in that area and swells coming from distant areas 1,000 or more miles away have entered into the area of observation. For purposes of distinction, the term sea waves and swell waves are used to identify them. The term sea refers to the waves formed by the winds within their fetch, or the condition of the sea when waves and swell appear together. At present, however, studies are still being conducted to determine exactly how the wind produces waves. So, ang pagkakaiba at parehas ng swell waves at sea waves, ang swell waves ay ang alon na nagmula sa malayong lugar na kung saan sila ay nabuo, at ang tsura nito ay oily kung titingnan ito sa itaas at maliit lamang ito kumpara sa sea waves. Ang sea waves naman ay ang alon na namuo within their fetch only. Kaya napagkakamalan na iisa lang ang swell at sea waves dahil kapag tayo ay nag-obserba sa isang dagat, kapag ang swell na nagmula sa malayong lugar at ang sea waves ay nagsama at nakapasok sa lugar ng ating pinag-oobserbahan, ito ay maikukumpara natin na magkapareho.
Wave characteristic and relationship. A simple wave is described by the following terms. Speed, usually measured in knots. Length, usually measured in meters. Period, measured in seconds. Height, usually measured in meters. Theoretically, following relationship have been established. Speed in knots, 3.1 multiplied by period. Length in meters equals 1.56 multiplied by period squared, where the period is in seconds. Height in meters equals 0.0214 multiplied by v squared, where v wind velocity in meter per seconds.
The decay of waves as they travel from the sea of origin. We know from experience, however, that there may be an appreciable wave motion on the sea surface. Yun daw po, may mga pinagtutuon ng pansin na wave motions sa ibabaw ng dagat, typically having a long wavelength in proportion to its height. Depende po sa haba ng wavelength daw at depende sa laki nito, sa taas. At yun daw po yung swelling. This is swelling. An olive broken surface is another characteristic of a pure swell wave. Yun daw po yung oily, broken surface ay isa sa mga karakteristik ng swell wave. These waves are commonly due to the action of strong winds in some distant area and may travel thousands of miles from their origin before dying away. Yun daw po yung mga waves na nagte-take actions siya gawa ng malakas na hangin sa kalayuan na kayang mag-travel nung agos niya hanggang ilang libong milyahe simula sa pinanggalingan nito bago siya tuluyang maglaho. The energy associated with waves of short wavelength is more rapidly dissipated than that associated with longer waves. Yung lakas daw po na itong alon sa may ikling wavelength ay mas mabilis siya naglalaho kaysa sa mas mahabang alon. Hence, in general, it follows that swell waves are long in comparison with the wind-driven waves at the place of observation. Ang kadahilanan daw po nito sa kabuuan na yung swell waves, mahabang pagkakatulad nito sa wind-driven waves. Kasi rin sa obserbasyon nila, hanggang matapos ito sa kanyang hangganan. As swell travels, its height decreases. Habang nagta-travel daw po yung swell, yung taas nito, unti-unti bumababa. The investigation by the Institute of Oceanographic Science shows that as the distance in nautical almanac from the point of the generation, then the amplitude of distance r is 300. R of the points of generation. So, base daw po sa investigasyon ng Oceanographic Science, makita daw po dito na yung R, yung tumatayong distansya sa nautical almanac. Yung R ay is equals to 300. Thus, a swell would lose one half of its length in traveling distance of 1,200 nautical miles. Ito daw pong swell, nababawasan yung height niya ng kalahati kada 1,200 nautical miles na nilalakbay nito. The long swell are the greatest travelers. All the previous remarks refer to waves in deep water. Yung swells daw po, isa sila sa mga nagtatagal. All the previous remarks refers to wave in deep water. When a deep water wave enters shallow waters, it undergoes profound modification. Kapag yung deep water wave ay masok na siya sa shallow water, yung bilis niya po ay nababawasan at saka yung direction ng motion niya medyo may iba. Speed is reduced, its direction of motion may be changed. And finally, its height increase until reaching a certain limiting depth. Yung taas nito lumalaki hanggang sa ma-reach na nito yung limit depth niya. The wave breaks on the shore. At hanggang sa maglaho na ito sa iga or sa pangpang.
Seiches. A seiches is standing wave in an enclosed or partially enclosed body of water. Seiches and seiche-related phenomena have been observed on lakes, reservoirs, swimming pools, bays, harbors, and seas. Ang seiches, ito yung paggalaw ng tubig na may yung tumataas at bumababa. Ito namang phenomena na to ay na-observe na daw sa lawa, dagat o kaya sa pool na may pare-parehas silang cycle. Yun yung tinatawag na seiches. In many places, the sea level can rise and then fall within a period of few minutes. Any such unexpected changes are known seiches. They are caused by sudden changes in weather, such as when an intense depression or line squall covering considerable area passes over. In this case, the heights are very unpredictable and can be anywhere from a few centimeters to more than a meter. At sinasabi naman dito, sa mga lugar na may tubig tulad nga na ng dagat, within a minute, pwede magbago ang water level. Tapos yung mga unexpected o hindi inaasahang pagbabago ng tubig, ay nga yung tinatawag na seiches. Kumbaga, nagbabago ito depende sa panahon. Kung nangyari, may bagyo, syempre malakas yung hangin, possible na tataas yung tubig nun. Kasi mapoform nun. Tapos, yung ano daw, yung taas ng tubig ay nga centimeters na pwede maging mas mataas pa sa meter. Ito naman yung ay niya, yung picture, kumbaga ayun niya, makikita mo yung ayun, still water level, yung sukat ng tubig. Tapos pag na anuhan siya ng hangin, magbabago, tataas yung tubig niya.
Seismic sea waves. Underwater earthquakes, landslides, or volcanic eruptions cause gigantic sea waves known as seismic waves and travel at a fast speed, often in the region of 300 to 400 knots. So yung seismic sea waves daw is galing ito sa mga underwater earthquakes, landslide, or volcanic eruption na nagdudulot ng malalaking alon at tinatawag na seismic sea waves. At nagta-travel daw ito sa malalakas na speed, lalo na doon sa region na 300 to 400 knots. Another name given to these waves is tsunamis, meaning harbor wave. Their speed depends on the depth of water in which they are generated, and they travel in all directions from the point of origin. So yung seismic sea waves daw is tinatawag din na tsunami, meaning daw harbor wave. Nakadepende daw yung speed nito doon sa lalim ng tubig, kung saan nangyari yung mga underwater earthquakes, landslide, or volcanic eruptions na nag-generate at nagta-travel ito sa lahat ng direction galing doon sa point of origin niya or mismo pinangyarihan ng mga underwater earthquakes, landslide, or volcanic eruptions. As they usually originate in the open sea, they are often barely noticeable at that point, but when they arrive in coastal areas, especially shallow areas, their height increases and can cause enormous destructions. So yung seismic sea waves daw talaga or yung tsunami is galing talaga siya sa open sea, kung saan nangyari yung underwater earthquakes, landslides, or yung volcanic eruptions. Tapos pag malapit na daw ito sa coastal area, lalo na sa mga shallow areas, yung mabababaw na tubig, yung height daw nito is lumalaki. Tapos nagdudulot ito ng malalaking pinsala, lalo na kung yung mismong papupuntahan nito is maraming tao or mga buildings, ganun.